Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone. Welcome to the Event Horizon here on Astronomy.fm radio. It is another Friday evening. This one is January the 18th, 2019, yes.
Get it right, Marty.
I got to get it right, yeah. Okay, I erased the 8 and I put a 9 in there instead. So, 9 o'clock in the evening for those of us here in the eastern portion of North America. Universal time, 2 o'clock in the morning, Saturday morning, January the 19th, again, 2019. So welcome, everybody. Of course, our chat room is open for you to come on over and join us. You'll find it at the homepage, astronomy.fm. It's easy to get here. Come on over. Ask us questions. Or don't ask us questions. Just hang out.
Yeah,
whatever.
it's kind of empty. Hi, Evil Spock. Evil Spock's there. And that's about it. I think just us. Well, what can we say? Snow apocalypse on the horizon. Big yawn. Thank you, ABC. I really do not appreciate getting bombarded with PMs from abroad asking me, am I all right? And is there 14 feet of snow? No, sorry, folks. ABC has got it wrong again. God alive.
Where is the snow apocalypse supposed to happen? If it's not me, I'm not really paying attention.
Well, it's supposed to be coming over from the west to the east. It's mostly lake effect snow, but we're supposed to get anything up to 14 inches of snow, depending on where exactly in New York State you are.
Okay.
I'm expecting a good two foot where I am, but as I say, Twisted Edge, great to see you, my friend.
Mm-hmm.
So
in the chat room.
Yeah, he's in the chat room. So whilst I think about it, the links will be on the YouTube show version of the show, which I will do probably tonight at this rate, because they cancelled my overtime for tomorrow.
Maybe that's good.
It's supposed to kick off at about 4 o'clock in the afternoon. So I've got some beer in for the curry, and I'm going to do a nice beef jalfrezi, got a nice bit of steak. And as I say, just going to relax. And as O'Neill would say, stay calm. Let Carter sort it out.
Relax and probably not enjoy an eclipse on Sunday night.
Hi, Graverman. I don't know. Maybe not.
All right, I'm gonna pull up a weather satellite picture and see what it's looking like. So maybe I give some people an idea of what part of the U.S. at least will be probably clear and what part might not be clear.
I'm also doing that. Dudley College in Schenectady, New York, has cancelled its Blood Wolf Moon party. I've got to remember how they put it. They've cancelled already.
Okay.
What else? I'm reading Susskind again. So
okay.
I've picked up a new Susskind for me.
Mm-hmm.
What was it I got? Oh yes, so the Cosmic Landscape, String Theory, and the Illusion of Intelligent Design. So that's currently my reading material. I finished Kip Thorne's Black Holes and Time Warps, I think for about the 15th time.
Okay.
Never gets boring. I always find new things from his description. Now, yes, this is something I posted on Facebook. Mostly because I was reading something and I really caught into my mind. Let me quickly scroll down. Cosmic censorship. Okay, back in 1969. Hi, Quiet in the Wood. Glad to see you here. Roger Penrose was strongly convinced that naked singularities cannot form. But, of course, being able to prove it, he proposed a conjecture, the conjecture of cosmic censorship. Basically, that no imploding object can ever form a naked singularity. If the singularity is formed, it has to be clothed in a horizon. Guess what? An event horizon. Why?
Exactly. Hey,
So
appropriate for tonight.
So we, the external universe, can't see it. And having said that, this has still stood the test of time. So well done, Roger Penrose. Now, of course, obviously, Kip Thorne's worked on it. Zadovich. Oh, Zadovich. Whilst I think about it, very important event we passed. I'm scrolling back on my phone. God love Facebook. It's so January the 16th was the 105th anniversary of the birth of Yakov Zadovich. Okay, who was Zadovich? He was one of the top Russian, top Soviet brains in physics, astrophysics, quantum mechanics, and of course he was part of their atom bomb team. So of course, this is the 100th. So with the 100th, well, the 100th anniversary was back in 2014. So that's the 105th anniversary of Zadovich's birth. And of course, amongst his many legacies is the Zadovich approximation for the growth of large-scale structure, which remains the most successful and incisive analytic models of structure formation. We still use it today.
All right.
So I'll put a quick link into that because, okay, come on, computer, you can do it. I've fed the Jaboas extra rations for this, so that and I'm on an octa-core processor. So
I pulled up a weather map for the U.S. by the way. So right now there is a clear spot over 2 states, North Dakota, South Dakota. Those are basically central northern U.S. So if those there's a clear spot there. If it takes just 2 days to come across, I should be good. If it just exactly 2 days, I should be in a clear spot. Looks like southwestern U.S. is in a semi-clear spot. So that means if that moves over to the mid-south U.S., that region might have a chance. Everything else is going to be scattered. There's in the northwest right now. The state's called Washington and Oregon. There's a big cloud bank, but if that rolls across, then there will be patchy skies for those states. And I think most of the East Coast is going to be clouded out, though.
Okay, so what do we use the Zadovich approximation for? Well, we use it to compute the 2-point function of matter and bias tracers, and we can compare the results of n-body simulations and other Langerian perturbation theories. What it also does, we can use this to extend the calculation of halo bias to third order and consider non-local biasing schemes, none of which will remove the discrepancy rather. And of course, we use it to the approximation to compute the ingredients in a Gaussian streaming model and to show that this hybrid method provides a good fit for clustering of halos in redshift space down to scales of tens of megaparsecs. Now, if you just keep in mind, I've been reading this stuff for the last few nights. Mm-hmm. So, yeah, my head hurts. But as I say, it's just one of those things. It was a tangent I went off. I was reading Kip Thorne. I just loved the way he just... And then I went back to Moscow, and it really... Yeah, okay, I enjoy astrophysics and the quantum side of it as well. It's good fun. Mm-hmm. But yeah, get it. Have a good read of it. It is rather. I wish Red Shirt 3 was here because he probably enjoy this as well. But yeah, what else can I think? Oh, SETI. Let's do a quick bit about SETI, shall we?
Oh, sure.
Okay, so there's this. How many people have heard about the SETI League? Well, what it is, it's a group of amateur radio astronomers, and what do? They are using their own home-built radio telescopes on a project called Project Argus. Project Argus is an ambitious global microwave SETI project. Now, the nice thing is, this is something you could probably actually do in your back garden. Because in reality, if you remember the old dishes, that we used to have for satellite TV, long before the days of
The big ones,
TV.
the big ones like the 8-foot diameter ones, or the small ones?
They're slightly smaller than the 8-foot ones. So anyway, I'm doing what I usually do. I'm following links. I'm looking up stuff. Actually, I was also in the asteroids and dwarf planet section of the British Astronomical Association, looking at their new exoplanet group, which I'm a member of, believe it or not, which is quite unusual. Since I'm a comic guy, but then again, why not? So anyway, what did I find? I found this thing about the SETI League, and an amateur SETI station, and it's a noted block diagram of what you need, what you can use to create your own SETI station. And you know what the really way cool thing about it is? The professionals out there really need your help. Basically, yes, we've got Arecibo. Occasionally, they may get time on other radio telescopes, maybe the SKA or something. But if you have a bunch of amateur astronomers with their own radio telescopes listening in at set frequencies for intelligence signals, you can actually cover the whole Earth within reason. It's like having your own interferometer. So anyway,
So this is microwave, right?
this is a microwave.
And microwaves can penetrate the atmosphere
It can penetrate the atmosphere, yes.
and our magnetic field.
Yes, because that is how we receive signals from satellites
Okay.
for TV.
Yeah.
Okay. So anyway, it's not a bad little project. This is the Dan Fox's setup. He's Kilo Foxtrot 9 Echo Tango GET. Good amateur radio call sign, that I suspect. But anyway, you can click on any parts of the image for details about the particular components, and it shows you what you basically need. Basically, the mount has to be modified to have the dish pointing vertical up at the sky.
Okay.
Do objects enter a black hole from any direction? Well, mostly they spiral in, because what happens is the black hole captures them and they just spiral in until they cross the event horizon.
Now, I want to add to that. It's mostly been thought that they all spiral in basically from a disk, kind of like
Accretion disk.
accretion disk. Yeah, that kind of goes around. But they've also found some black holes, this was found more recently too, that disks, they can have actually multiple disks going around the black hole that can run around in multiple directions, perpendicular directions. So most objects will spiral in. Very rare that something will actually just plunge in. They mostly spiral in, but they've recently proved that they don't have to all spiral in at the same plane. There are perpendicular and similar planes that they can spiral in from.
I think the main thing is where we've got used to having the accretion disk in one plane is because how we've actually seen the accretion disk. Bearing in mind, we don't see the black hole directly. We either see the accretion disk of hot gas and material, or we're seeing the jets coming out of off the accretion disk. I'm going to say off the accretion disk for a very good reason, because once something actually crosses the event horizon, it doesn't escape. Right. This is an area of gravity where it's so intense you cannot escape. So basically, you can possibly try a slingshot maneuver, but you will need a heck of a lot of power to do a slingshot around a black hole.
Yep. That would be well before you entered the black hole, by the way.
Oh, yes.
So also going to say, something that can, instead of just spiraling, something else that can make it semi-go direct in is if there's a collision outside the black hole. Particles collide, and then it could just fall straight into.
So as I say, a lot of it really does depend on how you are seeing the accretion disk. The newest facts really are that the black hole can have multiple accretion disks at various angles. So normally, yes, if we're looking visually, we may only see the one, but unless we're lucky enough to see something enter the black hole or get captured, that is an obvious clue to the fact that the accretion disk is at multiple angles to the black hole. And you all know what happens to a piece of matter when it goes as it gets closer, it gets spaghettified. It gets dragged out.
Depending on the size of the particle and the mass of the black hole.
Having said that, what does happen is information is not lost. And basically, when a particle enters, the antiparticle can escape, because you see the positive universe particle and the antiparticle, and it has been noticed that the antiparticle appears to escape the black hole. So
I was going to say also on that spaghettification. So if it's a fairly small black hole, like stellar size, yeah, you'd have a much more tidal differences in a shorter distance. But if it's a fairly large black hole, like galactic size, then the object basically will go in whole without being stretched, because the black hole is so big. So only when it's a small black hole, we get more spaghettification. Basically, the part closest to it will get pulled in much faster than the part opposite of it. Like a stellar black hole would be more like your feet and your head will get stretched opposite. Yeah.
And of course, you get squeezed in the middle as well.
Mm-hmm.
Okay, so yes, looking. I was looking for a nice little image I could put in, and I did actually find one on
a bowl of spaghetti.
No, actually, it's from curiosity.com.
Oh, okay.
I'm just copying the image address right now, so that should come up. Yes, it does. There you go. A spaghettified human being.
There you go. But it's got to be, a small black hole to do that.
Yeah. Now, the other thing, of course, about black holes is that does the Large Hadron Collider create them? Technically, yes. How big are they?
Well, I don't know if they guarantee that they made them. They just suspect that it's possible.
Yeah. But the really important thing is, even if they do make them, they are too small to feed. A black hole needs to, in order for a black hole to feed, it has to have an event horizon of a certain sized event horizon. The mini black holes, which technically could be created by the Large Hadron Collider, are too small.
They'd have so little material in it that it would probably evaporate out before it actually.
They actually do, Marty.
Before it would gain more material to build it up.
Actually, they do evaporate, but do you know how long they actually live?
Well, if it's a really, really small one that like a Hadron Collider might produce, it might be like it would evaporate in billionths of a second.
No, 42 minutes. 42, the meaning of life, the
42.
universe, and everything.
There you go.
Ironically, think about it. This is what Adams predicted. It is the meaning of life and everything, because it can only live for 42 minutes, and after that, it goes poof in Hawking, gives off Hawking radiation, and it's gone, never to be seen again. Or maybe it emerges as a white hole on another part of the universe. Who knows?
Yeah, I doubt it. I don't think that's ever been even.
No. Well, okay. So anyway, another thing I learned. When Carl Sagan was writing Contact, he made a phone call to Kip Thorne, and he says, "Okay, I'm pretty sure of this stuff about black holes, but could you go over the science, make sure I get it right?" So in the mail arrives the double-spaced typed copy of Contact from Carl Sagan. So Kip's wife and his daughter are very used to Kip being in the car, totally immersed in the paper as they drive around places. And he's reading along, and he gets to the bit about the black hole, and he goes, something wrong here, because you can't use a black hole to journey from one part of the universe to another. Possibly, theoretically, I'll use that word, theoretically, a rotating black hole might.
Or like hypothetically.
Yeah. Now, the important thing is, the only thing you could use to travel from, say, our solar system to Vega and cut the distance in half is a wormhole.
Mm-hmm.
Having said that, there's problems with wormholes because they're very short-lived and they need exotic matter to survive. Now, the thing is, the matter falling in from our universe, even a photon, could be enough to actually shut down the wormhole. So obviously this super duper advanced civilization that's contacted us and told us how to use this wormhole must have a way to keep it open for the spacecraft to go from one part of the universe to the other. As I say, this is where it's getting really, really hypothetical. So no, black holes can't do it, but theoretically, a Einstein-Rosman bridge, which is what a wormhole is, can do that. Not many people know that.
Mm-hmm.
Now, Evil Spock asks the question: does time slow down in a black hole? Yes. To the outside observer, or to the observer, yes, because as you cross, if you're the astronaut who's been stupid enough to try and cross the event horizon, it appears that time is slowing down. You're not. By the time you get to the singularity or the naked singularity, which is postulated to be there, you can get. Yeah, I've been reading too much Kip Thorne again. You are not even one piece. So at the end of the day, you've been completely and utterly crushed, ripped apart, and otherwise mangled. So by the time you get there, you're not going to see it. And as Roger Penrose pointed out, if naked singularities can exist, we in the external universe can't see them because they have a horizon. They've gathered a horizon around them to keep us from seeing it. And I don't really want to know if I want to go that far. Yes, time theoretically, hi Cassie, welcome to the chat, does slow down as you get closer and closer to the black hole.
And then stops once you hit the speed of light.
Well, at some point it stops because you stop existing anyway.
Well, yeah. Time stops for you because, because if you're at the speed of light, in an instant would take an infinite amount of time. So from somebody, observing, quote unquote, from the outside, it looked like you totally stopped your movement. From the inside, it would seem like you were using your normal movement, but any amount of movement, any amount of time passing at the speed of light, an infinite amount of time would have passed on the outside.
So, as I say, it's definitely, they're fascinating objects. They are really hot debate. There was
So the question is, how does anything move inside of a black hole if it takes forever to move? So, yeah,
as far as I'm concerned, nothing does.
That's the controversy in there.
Yeah.
Well, then you've got stuff coming in. So, how could something come into the black hole if as soon as it enters the outer boundary, it stops? That's
well,
weird.
As I say, once you cross the event horizon, you can no longer see it.
Mm-hmm.
So technically, you actually vanish.
So I wonder if you can never actually get to the inner part of it. I wonder if if it's just building up boundary layers, black holes. I have to look into that.
Yeah, because as far as I'm aware, once you cross the horizon, light can't escape.
Right. So nothing can actually travel from the outer edge of the black hole to the inner portion of the black hole because it would take all of time to do that. So it must be just building up a boundary layer.
Certainly, if you're the observer crossing it, if you're the external observer, basically you would see the object just disappear, really, or even perhaps even stop.
It's confusing.
Yeah, it is. It's very confusing. And Twisted Edge just put a link in. Concerning the paper that you just posted into chat, so I will save that. That will go into the notes for the show.
Okay, I put an article about black holes in here. I'll just give you the title if you want to read it. You have to figure it out yourself. It's Chandra views never before seen behavior from a giant black hole.
It's quite a fascinating article, actually. I was kind of looking at it whilst I was talking, which is a dangerous thing to do because sometimes you can actually get completely and utterly lost.
I know. I'll have to read it a little bit later, but it's in our chat room.
I suppose it's as safe as taking driving directions from Captain Slow.
And after our chat room, it'll be posted on our AFM Facebook page, right?
Well, what happens is all the links will go into the notes to go with the show once it's posted on YouTube.
Okay.
Because what's happening is that way all the links are fine, they work. Facebook, when you start posting big bunches of links, messes them all up. It cuts them up, and you can't get there.
Mm-hmm.
I remember I was actually working links for Space Pirates, and it was like link cannot be found. Link cannot be found.
There was a lot of that.
So, as I say, it's really a case of everything will be attached to the YouTube version of the show.
Okay, doke.
And even Scott points out that's what they implied in the SG1 episode. People were slowing down to near zero. And of course, the thing is, in SG1, they're using a stable wormhole to travel across the galaxy.
Mm-hmm.
There you go.
I was going to say, it's got a couple of meteor showers coming up. We'll get these in quick before the half hour here. Meteor showers, there are a few coming up. Tonight, there's one called the January Chi Ursa Majorids peaking tonight. We've got one peaking on also tonight, the Gamma Ursa Minorids. And then on the 22nd, we got Eta Corvids. And then on January the 24th, we got the January Coma Bernices meteors that you might see some. So a few meteor showers out right now. Not real prominent.
Covered by the snow apocalypse on the East Coast.
That's right.
Talking of that, of course, that means, there's a good chance I won't get to see the lunar eclipse. There's supposed to be quite a nice dark one this year. Mm-hmm. And of course, it can be seen from the west coast of the US all the way across to the UK.
Mm-hmm.
And the director of the BAA lunar section is asking people who get to see it to send in pictures and observations so that they can follow this up scientifically.
Okay, cool. Now, I used to give reports on where the moon was nearby each planet for the coming week, but I think that it's gone away because it was part of the U.S. Naval Observatory, and I don't think they're updating it during the government shutdown.
Nope.
That seems to be missing lately from their homepage. So,
tell you what is missing as well, Marty.
What's missing as well?
A lot of the United States Geological Service's moon maps,
mm-hmm.
They're also down. I get this message.
Okay.
Currently, service is not available for this page.
I went to something to do with NOAA, and that was down also.
Well, NOAA's an interesting conundrum because weather is a safety issue.
Mm-hmm.
So
wasn't a weather thing. It was something else to deal with them, though. I don't remember what it was. Timing thing or something.
Yeah. But I don't use them for timings. I actually use other sites for timings for events like eclipses, occultations.
Mm-hmm.
And Marty, it's time for you to do the bottom of the hour.
We're close enough. All right, let's go for it. You are listening to the Event Horizon here on Astronomy.fm radio. It is Friday evening, January the 18th, 2018. Sorry, 2019. The date's the 18th. It's 9:30 in the evening as our local time, and universal time that would put it at 2:30 in the morning. Yes, on January the 19th, 2019. Got that all twisted around and straightened out too. So we still got another half hour of live programming, and don't forget we got more programming coming up after the Event Horizon. First Light's not going to be on tonight though, but we will have an entire 4-hour block, including us, repeated every 4 hours for the next 24 hours. So if you don't catch us, or if you missed the first half, you can wait about another 4 hours and catch us repeated again. So some people do anyways, because it's sleepy time right now for some people.
Yes, it's like 2:29 in the morning for the UK.
It's everything around the world.
Now,
For everybody.
okay.
Why don't you say hi?
Events.
Why don't you say hi to first? Say hi to everybody in our chat room right now.
Okay, so hello to Sky Guy Nick, Sky Guy Marty, Evil Spock, Twisted Edge, Gravenman, Quiet in the Woods, and Cassie. Hello, everybody! Glad you can make it. IPAs
Yes.
for all, yes. Okay, coming up in February, February the 21st, aloha to the WM Keck Observatory. They are having a cosmic events, and Professor Alex Fipanenko, University of California, Berkeley, Professor of Astronomy, will be giving a lecture in the Kahailu Theatre about dark energy and the runaway universe. I did actually ask them, is this going to be streamed live? Sadly, no. However, there is some good news. Give it a week, and you can go onto their website, and you can watch the presentation. They're getting very, very good now. They have a section called Cosmic Video, and I'm just going to see if I can pull that up.
Okay.
Maybe I can't. But anyway, we're going to have an astronomy talk. Oh, we're just actually doing it. Yes. So it actually has things like Shining Light and Gravity, which was the Monday, December the 10th lecture. Dragonflies, Dark Matter, and the Hunt for Ghostly Galaxies, which was November the 7th. The Waimea Solar System Walk, which was October. Astro Day West Hawaii. The Monster at the Heart of Our Galaxy, Using Shadows to Shed New Light. As I say, they have some really, really good videos there. And there's one which really appeals to me, which was from March of 2018, Journey Through the Universe, Landscapes of the Moon and Mars. So, and that was a presentation by Brian Day, the lead for Lunar and Planetary Mapping and Modeling, Solar System Exploration Research, Virtual Institute, NASA Ames Research Center. So, as I said, he gave a demonstration of the lunar and planetary mapping and modeling portals his team developed at NASA. So, yes, there's some good stuff there, even if you can't go to the lecture live, which I wish I could.
Mm-hmm.
But, oh well, such is life. You can always give it about a week, and they will have the lecture up.
There you go.
So, definitely worth going to.
Got a little update on Saturn. Saturn, yes. They've actually kind of pinned down its rotational period. Let me put that article in our chat room.
Well, it's about time.
Exactly.
Sorry.
Hey, that should be my line there. What are you doing? I'm taking my...
Part of my cunning plan, Marty.
There you go. Where was that article at? Here we go. All right. So the problem is with most gas planets, it's actually hard to pick one spot and follow it around the planet and be able to get it accurate as to how fast the planet rotates. You kind of guess by looking at general features, but they don't really last very long. So it's hard to tell what the rotation rate is on a planet. So somebody finally came up with a way of figuring it out on Saturn. Now, one of the ways that I think they do with Jupiter is some of its magnetic fields. They tried that with Saturn. Didn't quite work. But they basically found a way that the rings interact with the rotation of Saturn, and they found some kind of resonance in the rings that were lined up with the planet, so they can time that resonant point in the rings and figure out the more accurate rotational period for Saturn. So it's come up to 10 hours, 33 minutes, and 38 seconds. Is now the official rotational period for Saturn.
Interesting factoid. In the book, The Sentinel, I believe, which was the story that kickstarted 2001: A Space Odyssey, the discovery actually goes to Saturn, not Jupiter, and it goes to Saturn's moon, Apaetus, not Europa. There's something you didn't know, did you?
Mm-hmm. Juno's sending back some pretty interesting images of Jupiter, because it just had a flyby from what's the name of that probe around Jupiter? Is it the Juno probe?
Yes, Juno probe.
Oh, yeah, of course. Juno, Jupiter, getting confused again. So I just had a close flyby of Jupiter, and they've got some new images, especially of the red spots. So check that out. Put this one article into our chat room also.
As I say, Quiet in the Woods is quite right. It's amazing that at the beginning of the 21st century, that the rotation rate of Saturn is still an active area of research.
Mm-hmm.
The gas giants will always be an active area of research.
Yes.
Because they are such a conundrum in our solar system. It's beginning to be thought that the gas giants actually form closer in, where the rocky planets are, and there was a switch. All the rocky planets moved inwards, and the gas giants moved outwards.
Mm-hmm.
Because at the end of the day, when you think about the classic model of the solar system formation, all the gas in the solar system is going to be closer to the sun. It's going to be in a hotter area of the solar system. Whereas the outer solar system, which is comparatively colder, is a much better place to form rocky planets through amalgamations and aggregations. So sometime in the solar system, there was an event which caused the gas giants to literally switch place with the rock cored planets. So of course, following these giant gas planets is always going to be an important thing for NASA. Purely, if anything else, to try and find out what the actual mechanism was that caused the switch in planetary location. Because at the end of the day, it would have been quite a major upheaval in the solar system. When you think there's Jupiter, Saturn, Uranus, Neptune, all switching locations.
Mm-hmm.
So yeah, there is a minimum orbit below which the gas giants don't survive. But were they blown out by stellar wind, but why did the solid rocky planets switch place?
Unless it was just a slingshot effect of the big ones moving out into the territory of the little ones, which actually flung the little ones in closer to the sun.
It's possible.
Yep.
We know that Jupiter does it on a regular basis still.
Mm-hmm.
A lot of the periodic comets that we see today are either Jupiter family comets or they're comets which have been perturbed by Neptune and by Uranus and by Saturn. So initially, the perturbation is done in the outer solar system by Neptune,
Mm-hmm.
and it knocks the comet into a closer approach to the inner solar system. Now, what Jupiter does, it does one of two things. Either Jupiter is going to capture it over a period of time, or it's going to propel it into the inner solar system it'll go through perihelion,
Mm-hmm.
and either it will be ejected, or it will come. The orbit will be that it will be. It's been captured on the outward bound part of its journey. So, in reality, the gas giants are double-edged when it comes to comets. For most of us, they are a godsend because of what they do. Having said that, they also could be the cause of some of the bombardments we've gone through in the past. Like I say, either Jupiter's going to hoover it up, and we'll have a Shoemaker-Levy 9, or it's going to send it it's going to paint a nice big bullseye on the Earth, the Moon, or Mars, or maybe even Venus. We know that Mercury was heavily bombarded because it looks exactly like the Moon in some characteristics.
Mm-hmm.
And we know from some of the pictures that were taken both by Apollo, by Surveyor, by LRO, and by the JAXA missions that the far side of the Moon, I say far side, I do not say the dark side,
Mm-hmm.
because when we have new moon, that's our dark side, and the far side has lunar day. So calling it the dark side of the Moon is very incorrect. Calling it a supermoon is also massively incorrect, because it's actually it's a size energy of the Sun, Earth, and Moon system. So every now and again, when we have full moon and it's close, we have this stupid thing called a supermoon being bandied about. It's an astrological term from 1979. Very inaccurate. And Twisted is actually saying there's models that have Mercury as being the core of a gas giant that lost its atmosphere. To be frankly honest, anything is possible.
You got to wonder about the late bombardment of that shows up the craters on the moon. Now, did that come when the planets were farther out or closer in?
Well, the thing
I don't
is,
know if I've ever seen a timeline on that.
No, we don't really know because it's thought that at the time that the Earth switched orbit, so to speak, we didn't have a moon. The Earth's moon, at best, is believed to be the result of the collision with a Mars-sized planetoid and the Earth, and the material. Super Sun. That's a good one, Marty. I must admit that's a good one. We have now a lot of common minerals, both on the Earth and the Moon. We have olivine, which is a shared mineral. And the only way you could have got olivine on the Moon as is if the material that created the olivine came from the Earth. Because we know it is a common material here, and it is beginning to be found to be a common material on the Moon. That, and of course, there are other metals.
And meteorites, too.
And meteorites, too. But the majority of it seems to be very, very much chemically the same as what we have on the Earth. So, as I say, who knows? I tend to go along with the idea that the Moon formed later, after the gas giants had switched places with the rocky cored planets, and it may be 20 years, 50 years, 100 or 200 years in the future, we may prove the theory is Mercury the core of a gas giant that lost its atmosphere. That we just don't know. Right now, we will never know because it's not a place really you can land a human. Our probes there have enough problems as it is, and sending the size of the refrigeration unit you would need.
Was there? Well, I don't know if there's ever been a probe landing on Mercury or not yet.
Nothing's actually landed, but they've gone into Mercury orbit.
Yeah.
It's just too hot at the surface, or the sun-facing surface.
Well, yeah, it's like 800 degrees, I think. Yeah, 800 for Mercury and 900 on the surface of Venus because the atmosphere traps more heat, even though it gets more heat.
And the other problem with Venus is the sulfuric acid rain and the gravity.
On Venus, yep.
On Venus, yes.
Well, gravity is equal to Earth. It would be the pressure of the atmosphere.
Yeah. Atmospheric pressure. That's the best thing. That's the best way to put it. Yeah, atmospheric pressure.
Mm-hmm.
So in a way, Venus is a glaring example of what happens when you have a runaway greenhouse effect.
Yes.
And that's something we really do not want on this planet. No way. Then we will all have to evacuate to Mars.
There you go.
Leaving certain people behind. Sorry, I just had to get that in.
Of course, that's okay.
So, what else can we do?
Let's see. What was I going to talk about? Of course, Bennu.
Bennu, yes.
What's the satellite going around Bennu?
Osiris.
Yep, of course, that's gone into a close orbit, the closest orbit around another celestial body, and it's going to be about another 6 months, I think, before it actually starts taking a sample from the surface, but it is in close orbit, so we've got some good pictures there. Of course, Ultima Thule, past New Horizon, passed by Ultima Thule, we got some good information there. But
it's a snowman!
I hate when people say snowman or bowling pin and all that stuff. I hate when they name little things like that. Yeah, whatever. So it's still more about a year and a half more to get all the data out of that space probe sent back to us. It was easier just to collect it and store it and send it back in smaller packets. A lot easier that way.
Well, what's happening? Okay, so there's been a second data release from the Gaia mission, and it's actually resolving a decades-long controversy about the distance to the Pleiades star cluster. Now, the cluster is about roughly 450 light years away towards the constellation Taurus.
Mm-hmm.
So what's happened is, previously we thought we had this nailed down. Now, what we did do was we actually, at the end of the 20th century, ESA designed a space telescope to measure stellar parallaxes. the high-precision parallax collecting satellite Hipparchus, named after the Greek astronomer, from the 2nd century BC. Now, it had a predefined set of stars over 4 years, and that gave us the Hipparchus catalogue published in 1997. And it gave us precise parallaxes for a little more than 100,000 stars, all within 300 light years of Earth. The precision was about 1 milliarc second, which is 1,000th of an arc second.
That's pretty tight.
Yeah, so it's like an astronaut standing on the. It's like seeing an astronaut standing on the moon from Earth. Now, the most notable distance is to the famous stellar cluster, the Pleiades, Messier 45 and Taurus. This is a group of bluish stars easily visible by eye in autumn skies. Now, Hipparchus found a distance of roughly 380 light years, rather less than the 440 light years of previous calculations, which were based on star brightnesses and consideration of stellar physics. I refer you, of course, to Sky and Telescope, June 1999, page 40. So this is a little bit embarrassing, folks. So Hipparchus says 380. We figured 440. Now, if on the one hand the astronomers we as astronomers have been using the wrong distance for the Pleiades, it has implications on a much larger scale. They are a nearby open cluster. They're frequently used to test our models of stellar evolution, and more importantly, to calculate the distance to further stars. On the other hand, if Hipparchus was wrong, then the dubious results would definitely challenge the entire catalogue. So I'm actually reading my current Sky and Telescope. Okay. So the importance of being clumped. Open clusters, they're very crucial because they form together from the same interstellar cloud, and we know they're all around the same age. So they are obviously excellent laboratories to test physical models of stellar evolution. What's happened is, of course, the Pleiades have always been a keystone for this, and the controversy has always been that if we've got this wrong, then what else do we have wrong? Mm-hmm. So what's happened is they now believe they have the Pleiades at a parallax in milliarc seconds of between 6 to 9 milliarc seconds. I'm just trying to. Okay, so what they've done, with Gaia, they've got a very precise final result of 7.317, which is plus or minus 0.002 mass, which corresponds to a distance of 445.8 plus or minus 0.1 light years. So if now through Gaia we have an accurate fix, we are going to have to really reevaluate the Hipparchus catalogue. Mm-hmm. Because that was, for a while, that was the best. It had it as being less. The old-fashioned figure was 440. Gaia is now saying it's 445.8, which basically means all the previous work pre-Hipparchus is pretty much all right. Our stellar physics are pretty much on the ball. Mm-hmm. Okay, they haven't relinquished all their mysteries, but now that we have a much more accurate measure, when we are using them to work out the distance to other stars, we know that using the Gaia results, we are getting fairly accurately the correct figure. So moving forward with research, that means stellar physics is A-OK. And we now have a better measuring stick than previously before. Anyway, if you want to read more, grab yourself a copy of this is the March 2019 Sky and Telescope. Okay. In other news, our good friend from astronomy.com and Astronomy Magazine is currently in London. He's doing gigs with Dr. Brian May for
musical gigs.
Actually, no, they're actually talking. It's actually more of a verbal.
Okay.
So, as I say, again, this is something that I picked up on Facebook. It's just really amazing. And he's actually going to be there, and he's going to shoot me because I forgot David Eicher. That's it.
Oh, well, why'd you ask it? Yeah, I didn't know you're searching for his name there. Okay.
Yeah, I was for a few seconds. David Eicher is doing these presentations, and he will be at Astrofest in London in February for one of these.
Nice.
And it is everybody's, of course, all my friends over there who've got tickets for that day are all hoping and touching wood and other things that Dr. Brian May is going to be there as well. And he has actually released a single to commemorate the Ultima Thule mission.
Mm-hmm. Well, since we're on the Pleiades, let's talk about the Pleiades a little bit.
Sure.
As we said, well, we kind of got the age established in it. Pretty popular group of stars called an asterism, which means it's not a constellation, but part of a constellation, and part of the constellation of Taurus Bull, which is an ecliptic constellation, so visible from northern hemisphere and southern hemisphere. This is a little group of stars that people have quite often confused for the Little Dipper, because it does look like a kind of a miniature version of the Little Dipper. So that's what people think.
I want to disagree there, Marty. The only way it looks like a miniature version of Ursa Minor is due to the fact it's also the car badge, and it's also in Japanese. The Pleiades is Subaru.
Yes.
And if you look at the car badge, I guess you could say yes, Ursa Minor.
Yeah, to people that just don't know, they think that the Big Dipper is really bright, so the Little Dipper must be really bright. Well, no, the Little Dipper is really dim, but they see the Pleiades, and it's pretty easy to pick out the general pattern of those stars. So that's where they confuse it a lot. The stars are pretty young; they're only about 100 million years old, and that's about their half-life. So these stars are not going to last very long. They're very blue stars, very hot stars, and they very short-lived because of that temperature. That means they're burning hydrogen, converting it to helium rather quickly. Now they're surrounded by a cloud of gas, even though you can't really see that without photography. Been some discussion. I haven't heard the latest on it, but thinking that cloud of gas that's around them was not from the original formation, but maybe just a cloud of gas that the stars happen to be forming in or passing through, actually.
Well, I would say that it's a reflection nebula.
No, you definitely reflection nebula, but they think it was not the nebula that formed the stars. It just happened to be a cloud of gas that the stars are moving through. It's reflecting the light.
Well,
of those stars.
What it is, the radiation from the stars is causing the gas to glow.
Not in a reflection nebula. It's simply the blue light bouncing off the gas. Yes, because otherwise
it's a reflection nebula.
Yeah, it's reflection nebula, so it has to reflect the light, but not actually excite the atoms in the gas and have the atoms in the gas glow. That would be what's the other term for that? Ionize. I can't quite pull it out right now, but reflection means it's just basically they're kind of shiny like a mirror, and the light's hitting them and bouncing off. That it's not actually causing the particles of gas to energize and give off light itself, just reflecting. Now, if you recall the Earth, that the amount of time the Earth's been about 4.5 billion years old, and it's thought life first formed on the Earth about 3.8 billion years ago. So that's a span of about 700 million years. Yeah, about 700 million years. That took life from the formation of the planet and the sun to actually come into being. Now, if the Pleiades are only 100 million years old, and it took life on Earth 700 million years old to get started, that means that if there's any planets orbiting around those bright blue stars, they probably have nowhere nearly had enough time to form life. So my point of this is there are no aliens coming from the Pleiades, all right?
Okay, I've just pulled up this.
that's a big thing. Yeah, people say that they talk about the Pleiadians, this race or something that's been traveling through space and has come to the Earth and whatever, blah 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 blah. As well, if you know anything about the Pleiades, the stars are too hot. They haven't been around long enough, and they're not going to last much more than about another 100 years. So they should have formed and then basically blown themselves up before life even would have had to start on any of the planets in that area. So if you hear anything about Pleiadians, people.
Let's face it, the amount of radiation those stars are giving off,
exactly,
is going to be completely and utter anti-life, totally.
Mm-hmm. Yep.
A reflection nebula is a cloud of gas and dust reflecting light from other stars.
And go for the other nebulas. There is a dark nebula, which means the light's being absorbed, basically shadowed. And the other one is, what's the other one called?
Absorption nebula.
Absorption nebula, is that what it is?
Okay, a dark nebula or absorption
emission nebula. That's what I was looking for. Emission nebula.
Yeah, is a type of interstellar cloud that's so dense it obscures the light from objects behind it, such as background stars and emission or reflection nebulae. Mm-hmm. And of course, I've got links for these. Don't worry, I'll make sure they get.
Yeah,
but
go ahead. I was thinking of emission nebula, where the energy from the stars actually causes the particles in the gas cloud to physically glow and give off light.
Well, there's a link to dark nebula. I'm just making sure that Starstorm, folks, in case you're wondering, is not feeling very well tonight. So I'm doing double duty. I'm yakking to you guys, and I'm also doing the links. Okay, so a classic absorption nebula is the Horsehead.
The dark part of it.
Yeah. So let me just
the glowing part around it would be emission nebula.
Okay, so an absorption nebula. It obscures the light from behind the stars. Yeah, that's pretty good. What are the three types? So the three types are emission, dark, and reflection.
Yep. Prime example of a nebula that has all three is the Trifid Nebula near Sagittarius Scorpius. It has all three types of nebula in it.
And if you're feeling incredibly eager and interested, I'll put a link to a study.com unit on emission, dark, and reflection nebula for you. How's about that?
There you go. You can see a good example of nebulas in the constellation of Orion the Hunter. Just below the belt of Orion is considered the sword of the Hunter. And that sword, if you notice, it's a little bit fuzzy. Yes, that's actually gas in space. That's being lit up by the stars within it. The four main stars called the trapezium. So that's one of the easiest ways of seeing a nebula. You can see it with binoculars.
Yep. And as I say, the thing is, some people can actually see the outline, certainly, of the sword. Mm-hmm. To be honest, the best way to see the trapezium is to image it.
Yes. Well, nice refractor will work too.
Yeah, but you really, if you're going to do it as a visual observer, you're needing to use averted vision. So I'm just making sure that
the trifid, the trapezium.
Well,
trapezium, the stars, the four stars, are pretty easy to see with any type of telescope. You just need some pretty good magnification to separate them. The nebula all around it's actually easy to see with a pair of binoculars, and pretty much any telescope will show you the emission nebula coming out of there. And that's where new stars are actually forming right now.
Mm-hmm. Okay, now the away team is being told we have 2 minutes to beam out.
We got like 45 seconds before we want to get out of here, so we'll start to wrap it up, and then we'll call the ship. Sorry, I don't have any exit sound tonight. I didn't get a chance to get some. So I want to thank everybody that's been listening in tonight. Really appreciate it. Don't forget, we've got more programming coming up, and we repeat this program and the rest of them every 4 hours for the next 24 hours.
And of course, it will be on YouTube as well very, very soon. Okay, Captain Savage, this is the away team. This is Nick and Marty. We're ready to beam aboard. We have our samples, and I don't like what's coming nearby, so please beam us up immediately.
Thanks, everybody. Appreciate you being here. And thanks, everybody that's been in our chat room tonight. Really appreciate all of you being here. See you all next week. Good night.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
There I was, doing my thing. And all of a sudden, wham! Astronomy right between the eyes.